Hi everyone, Mr. Neighbor here, and we're here to talk about the last section of Chapter 16, 16.4, Refraction, Lenses, and Prisms. So first, let's talk about mirrors. Two types of mirrors, concave mirrors and convex mirrors. So concave mirrors are mirrors that curve inward. So they magnify the image of an object being transmitted, so it appears close when it's really not. For example, this would be a telescope or microscope. So an object its light source comes in from that object, and then it gets reflected, and it gets reflected so it appears closer to the focal point. Convex mirrors do the opposite. They curve outward, so it shrinks the object. The object appears to be small, so it appears far away, but it's really not. So the light rays come in, and then they get reflected out, so it appears like they came from a source further away, making them seem smaller. For example, your rear view mirror does that. If you ever look at your rear view mirror on the passenger side, it will say objects in mirror are closer than they appear. It's because the rear view mirror is a convex mirror. By making it convex, we actually can see more of the area behind the vehicle. But what it also does is it makes those things that we're seeing seem like they're coming from a light source farther away, but they're not. They're actually coming from a certain distance away that's closer. So that's why they appear farther away, but then they appear farther away but aren't. So objects are closer than they appear to be. Next, let's talk about lenses. Lenses are just a group of concave or convex mirrors, but it's glass and light travels through them. So before we had a concave mirror, which made objects magnify, made them bigger. When we have a concave lens, we have one here and another here. So it's like two concave mirrors, and they will shrink the object being viewed. It corrects nearsightedness. It's kind of like peepholes. It brings people into focus. We'll see some slides about how this works with glasses in a bit. But for right now, see the light rays coming in. Once it hits, it gets refracted. And then once it goes through the other one, it also gets refracted again. So it's bending the light, making them appear smaller, shrinking the object. Convex lenses are like two convex mirrors combined back to back. That magnifies the image instead of shrinking it. So it's kind of like the reverse of what was happening before. And it corrects farsightedness. So the ray of light goes in, it gets refracted down, and then refracted again. So convex mirrors, they correct farsightedness, and they're like a magnifying glass, taking the light and focusing it closer. All right, so eye defects. There are various forms of why you might need glasses. One reason might be because you have myopia. That is nearsightedness. Nearsightedness means you can see near. Far objects are not very distinct and are fuzzy. So the image is focused in front of the retina. So retina is right here. Here's where the image should be focused at, but it's not. It's focused in front of it. So as the light passes, it starts to deflect. And when it finally gets notice, you have one point hitting here and one point hitting one, focusing at more than one with myopia. So we use a concave lens to go ahead and correct that. So the light goes in and it gets bent further so that the eye will then bend it, and it will be bent at the back of the retina now because it has to bend it further. So it was right here, Now with the lens, it's putting those two lines right here. So it has to bend it just a little bit further, and then it hits at the back of the retina where it's supposed to be. So now let's look at hyperopia. That is farsightedness. Farsightedness means you can see far, but you cannot see near. Objects when reading are blurry. So that's when the image is focused behind the retina rather than upon it. This occurs when the eyeball is too short or the refractive power of the lens is too weak. So you'll notice that it's supposed to focus right here, but the image is focusing back here. So we need it to focus closer. So if we put a convex lens in front of that, it makes the light go in sharper. So instead of going in like this, it might go in right here. And then when the lens refracts it, changes the direction, it's going to be focused sooner than it would have been otherwise because it's already been refracted a little bit by the lens inward. So it corrects it so it hits at the back of the retina like we want it to. So reasons why you might have these eye defects. Sometimes it's just something you're born with where your eye is too long. That would be a case of myopia. See how it's longer than the normal eye. Or same thing with hyperopia. Maybe your eye is too squished together. The more common reason why people have eye defects is because of age. As we age, our body doesn't work quite right, and it deals with the muscles, the muscle in the eye right here. These muscles change where the focal length is. So by widening or closing the lens, it refracts the light at different points, more or less refraction to hit back here. That's why, or let me back up a step. You can't just see everything in crystal clear focus like a camera would. Your eyes focus on a specific thing, like movies are typically made. They have a focus, and then that focus might go out of focus to focus on something in the background versus the foreground. So that's what your eye does. It can't just see everything crystal clear all the time. It has to focus things. So as you age, that the muscles that control that lens to help you focus don't work as well. So if it's not working well, then it might not be able to focus it in such a way that you can see near objects or far objects. It's just a matter of age and those muscles weakening. So we use lenses to help out where the muscles now can't help out. Another eye defect that you might be familiar with is astigmatism. Astigmatism is more complex than the two that we've had before with nearsightedness and farsightedness. With astigmatism, the light rays do not at all come to a single focal point on the retina. Instead, some focus is on the retina and some focus is in front or behind it. This is usually not caused by a non-uniform. This is usually caused by a non-uniform curvature of the cornea. So this is a normal eye. You're focusing just at one spot, but with astigmatism, you're focusing at multiple spots, maybe near, maybe far, and the letter appears to be blurred and out of focus because of those different spots interacting with each other. Another point of interest, you might notice bifocals, trifocals, and progressive lenses. What bifocals are, you're essentially having some concave and convex mirrors or lenses in these. So one will view far away while the other part will view near. So this part right here will help you view the far-sighted stuff, and then this part right here will help you view the nearsighted stuff. Trifocals can do a couple things, helping with astigmatism. They can help that those couple points come into focus by having a couple different lenses right there. And progressive lenses are just a gradual release of the concave to convex combination. So there's not this distinct contrast. It's more of a progressive decline from the convex to the concave lens. So it blends more easily. In the next video, we'll talk about prisms, and then we'll be done with chapter 16.